Hi everyone, this is Mishal Khan, and today in this video we are going to practice the angle sum identity for sine function. So as you can see this question, here I have this question. Let's solve this. So they are saying that use sine a plus b equals sine a cos b plus cos a sine b. This is the identity basically for sine angle sum of sine. And to find 5 pi over 12, so 5 pi over 12, this is angle in the radian, so it equals to 75 degrees, which means find sine 75 degrees using this identity. So how can we do that? How can we find that? It's very easy. So first of all, this sine 75 degrees, first of all we have to make two pairs of it, like we need to find the sum of it, so we can take any two. Let's say we want to take sine 30 and sine 45, because 30 plus 45 is 75. And one more thing about this identity, like the sine a cos b plus cos a sine b, so you can write it the other way, like sine b cos a, that doesn't matter. So now I can write like sine, it's thick, sine, instead of 5 pi over 12 which is 75 degrees, now I'll write pi over 6. So what is pi over 6? Pi over 6 is basically 30 degrees, plus pi over 4. What's pi over 4? Pi over 4 is 45 degrees, so 30 plus 45 is equal to 75 degrees. Okay, so now we have two angles, the sum of two angles, sine a, which means sine a, so sine, let's say this is our a and this is our b. So then sine pi over 6, not plus, sorry, cos b, there is no sign between them, which means they are in multiplication. Cos b, which is cos pi over 4, then plus cos a, means cos pi over 6, and then sine b, which means sine pi over 4. Okay, so now we will substitute values in here. Okay, so let's get on with it. Let's substitute the values. Sine pi over 6, which means sine 30 degrees, is equal to 1 over 2 times cos pi over 4, so pi over 4, which is 45 degrees, so cos 45 is 1 over square root of 2. Okay, now plus cos pi over 6, which is square root of 3 over 2, times sine pi over 4, which is 1 over square root 2. Okay, now let's multiply them. So 2 times square root of 2 is 2 into square root of 2, then plus square root of 3 times 1 is square root of 3, and over 2 times square root of 2 is 2 into square root of 2. Okay, now we can add them because denominators are the same, so we'll just take one denominator common, 2 into square root of 2, and then just add the numerators, which will be 1 plus square root of 3. So that's it. this is the value for sine 5 pi over 12. Sine 5 pi over 12. I wrote 5 over 12 here because pi over 6 4 equals 5 pi over 12, 75 degrees. So there you go, this is your answer. Okay, now let's practice another question, the same question, like the angle sum identity. So now the angle sum identity for cos, what will be the sum, how can we solve a question? So let's see an example. Okay, so here we have a question which is prove that cos 3 pi over 2 plus x equals sine x. So basically 3 pi over 2 is 270 degrees, and this is radian. So this is now the angle sum identity of cos, which is, let's say this is A and let's say this is B. So if you want to prove this, then we will take this left hand side and the right hand side from that. Okay, so the identity is, let me write down the identity first. The identity is cos A plus B equals cos A cos B. If this is plus, then this would be minus. If this is minus, then this one would be plus. You need to be careful there. Then sine A sine B. There we go. Now we just need to plug in the values. So cos 3 pi over 2 plus x equals cos A, which is cos 3 pi over 2, then times cos B, which will be cos x, as this is or A, this is or B. Okay, then minus sine A, which will be sine 3 pi over 2, sine B, which will be sine x. Okay, let's see now. This is pretty simple, as cos 3 pi over 2, which means cos 270 degrees, is 0. So 0 times cos of x is again 0. I'm gonna stick to the 0. Minus sine 3 pi over 2, which is minus 1. So minus 1 into sine of x. Okay, so we don't need the 0 there, because 0 minus or plus something is again that thing. So minus times minus is 1, plus 1. Minus times minus 1 is plus 1, and 1 times sine x is sine x. So there you go. Proved. We proved that cos 3 pi over 2 plus x equals sine x. Okay, just last question of the video. Let's practice now the we have now the identity as the which required the tangent and the square. Okay, let me give you the question, now you'll see yourself. Okay, so there we go. Here I have a question there which says prove sine x cos x tan x equals 1 minus cos squared x. So in this question we will practice two identities. We'll practice two things. One is, let me write it here, which is sine squared x plus cos squared x equals 1. This is an identity which we'll use in this question, and the other one is 10x equals sin x over cos x. Okay, so we're gonna use these two things in this question. So let's get on with it. First of all, sin x, cos x, and then instead of 10x just write down sin x over cos x. There is no sign between these three, which means they are in multiplication. So now what I just did is just take the left hand side, and now I will derive the right hand side from this statement. So these both can be cancelled with each other. Now sin x times sin x is sin squared x, sin squared x. Okay, now just look at this, sin squared x. So what would be sin squared x equals to? Just shift this cos squared x to the other side, then it will be squared x equals 1 minus, because this cos squared x is here positive, when you shift it to the other side then it becomes negative. So then it would be cos squared x. That's it, proved. 1 minus cos squared x. So sin squared x equals 1 minus cos squared x, the required proof. So this is exactly what we were required to prove. There you go, that's it. Okay then, that's all for today. Thank you very much.